All right, today we are taking a look at integration by parts from chapter 7 in this course. And essentially, I'm just going to start by introducing kind of what that looks like. So in order to integrate something, pretty much that has two pieces to it, right? Two parts. We have this formula. So if we have these two parts, call them u and dv, then we can set that equal to, or essentially transform it into something new, right? Using this integration by parts formula. So in order to do that, we have to figure out which part's u and which part is dv. So I kind of usually will set up u and dv in these little sections, and then my du and my v as well. But it might be a little challenging to kind of select what each piece might be. So this is something that I recall learning that kind of helps me pick out whatever u might be. I could always guess, figure out if it works, and kind of go from there. But I found that this kind of helps, and I remember seeing it in high school to just, pretty much give yourself kind of a foolproof way of figuring out in order what the first thing you might select is. So in this case, the first thing I see is algebra, just x. That's going to become my u. So from there, I'm going to take the derivative of x. I get 1 dx, and then that by default makes my dv e to the x dx. And if I integrate that and go backwards, I still get e to the x, right? So as I'm setting up now, I'm going to use this formula right here to plug my things in. So uv is going to give me x e to the x. And obviously this is still solving the problem above. So we're saying that's equal to u times v minus the integral of e to the x and then 1 dx. So if we continue further, this gives us something that is actually able to be integrated instead of what our original problem was. It's not causing us issues anymore. So my original x e to the x still stays the same, but yet again, if we integrate what we have here, we get e to the x, and we can't forget our plus c for that constant that could always be there. So there we go. We found our final answer. We could always check by differentiating that to see if we can get back to our original problem. But it looks like we've got the answer here. So for number 2, very similar case, but maybe, a slightly different outcome. Because now when I look and I want to select my u and my dv, it looks like natural log is what comes first. So in this case, natural log of x is what I'm going to pick for my u. That defaults my du to 1 over x. And then that also defaults that x squared becomes my dv. Oops. And then that means my v, we have to integrate x squared, getting x to the third over 3. So now, yet again, we can use all of this to figure out how to get our final answer, right? So we're still integrating our original problem. Maybe I will copy and paste that and say, well, now this is equal to uv. So u and v would be our top pieces. So I'm going to say just x to the third over 3 times natural log of x minus whatever this next integral might be. And that is v du. So in this case, if I'm really taking x to the third over 3 times 1 over x, I might end up, instead of doing that, kind of just scratching that and actually multiplying them across regardless and then dividing. So that'd give me still x squared over 3 dx. Now I can integrate that a little bit easier. And so our final answer ends up being keep what we have at the front, and then when we integrate, we raise this power, x to the third, and then we're going to have to divide by 3 again, so essentially that becomes over 9. Can't forget our constant. That gives us our final answer. And so that is about it. Now, both of these examples do have to do with, natural log, e to the x. There's a lot of different things we could have seen, like trig and other kind of examples, but I thought these were two good ones to kind of go over the basic idea. So thank you for watching.